So hello everyone, hope you're doing good and welcome back to my channel. Today we are at day 10 of the July daily Leetcode challenge and we have again an easy level question in front of us. Previous few questions were on the harder side. Let us see what today's question is. So we are given a basically a binary tree. Let's see it's question 111. Minimum depth of binary tree. So we are given a binary tree as you can see in the input. The input is basically root, okay? The root of the tree is given to us as the input, okay? So let's see, one thing I will tell you if you're a fresher, then like, if you're a beginner, what I will say is that see what you're seeing here is not basically the kind of input which you're going to get. Okay, see the input here. You're just going to get a root, which is basically a object of this particular class. Okay, so definitely it will have members. It will have these member functions, data members. So don't think like we will be given array something like that. Okay, it's not array. Basically, it's going to be a root. Okay, root is basically kind of a object of this particular class. You can also call it as a pointer pointing to the object of a such a class. Okay, if you are doing it in C++. So yeah, let's see the question now. So we are given a binary tree. Binary means any particular node will have at most two children. Okay, a left children and a right children. That's why you can see here we have this point. These data members. If there are more than two children, then definitely we can't use only left and right. We need something else also, right? That's why in this case it's a binary and we are having left and right children. Okay, the minimum depth is the number of nodes along the shortest path from the root node down to the nearest leaf node. Okay, so not a leaf node with no children. Okay, what is a leaf node? It's a node basically with no children. Okay, in this example, let's deep dive into this. Okay, so you can see that 3 is the root. Okay, 9 is a leaf node because it do not have any children. Similarly, 15 is a leaf node because it do not have any children. Similarly, 7 is a leaf node because I do not have any children. So please, spend some time on the terminologies. If you are not from a CS background, then definitely you have to, big, deep, you know, you have to dig deeper. So this is a root and this is a leaf. So basically, you can think of it as a, upside down tree. Okay. So what we have to do is we have to find the shortest path between the root and the leaf. Okay. So how the shortest path is defined? The minimum depth is the number of nodes along the shortest path. That means, see here, see in this case 3 to 9 form the shortest path. Okay, so because the only two nodes are involved. If I talk of 15, the distance between 3 and 15 is going to be 1 plus 1 plus 1, which is 3. Similarly, if you talk about 3 to 7 distance, it's going to be 1 plus 1 plus 1. So basically the idea here is any path which you are taking from the root to the leaf, we have to count the number of nodes involved in that. Okay, that is going to be called the minimum depth. Okay, and ultimately the question is you have to return the minimum depth. Okay, given a binary, find its minimum depth. Okay, this is the question. And what is the minimum depth? It's basically, see, you are following a path from a root to a leaf node. Okay, in between you will witness some of the nodes. Okay, you have to count those nodes, and the minimum depth of that path is going to be the number of nodes which you have witnessed. Okay, for example, if I talk about 3 to 9, 3 is a root, 9 is a leaf, so only two nodes are involved. Okay, so this is the minimum in this case because the rest of all the paths have number 3 nodes. Okay, we will witness 3 nodes. For example, 320 and 15, 3 nodes are witnessed. 3, 20, and 7, again 3 nodes are witnessed. So only 3 and 9 is the shortest because only 2 nodes are witnessed. Similarly, you can draw this graph and you can find this answer. Okay, so this is going to be a very easy question. Okay, this question is definitely on the easier side. That's why it marked as easy. We'll see how it works. So you just need to know the basic DFS traversal. Okay, what is a DFS traversal? Basically, we'll go into the depth of one branch, then we'll come out and go into the next branch and so on. Okay, the other comparative approach is going to be a BFS approach. Okay, DFS and BFS. So many algorithms will use these two approaches, but in this case, we are directly going to use the DFS algorithm. Okay, we'll see how. See, because we are talking about the minimum depth. Okay, that's why I'm starting with my answer with the maximum. Okay, that is the maximum possible floating point value. Okay, then I am defining a function called DFS. Okay, what are the two parameters it will take? It will take a node value and it will take its level value. If a level is not passed, it will make the level as 1. Okay, what is level basically? Level in this case, like in this particular case, level refers to how many nodes we have witnessed till now. Okay, so when we talk of the root, see, if I don't pass any value, it will take us 1. Okay, that's what the idea is. Level basically refers to in the current path how many nodes we have witnessed. Okay, this will be my answer when I reach the leaf node. Okay, so how this function will be called? This function I will call it on the root. I will not pass any level here. Okay. This value I will not pass in here. Okay. That means the default value will be used. That is level equal to 1 will be used for the root. Okay. As we go down, you can see level plus 1 will be done. Okay. Now see here, see just for a second, ignore these things. Just come here. What we are doing? Every time I am from the root, I will be calling one of its child. Okay, for example, the left child, and so on. Okay, what, so I will just test and show you how it works. For example, from 3 it will go to 20, then from 20 it will go to 15, then it will come back to 20 and it will go to 7, then it will come back to 3 and it will go to 9. That's how it will work. That's what the DFS is basically. Okay, in this see particular question, we are not discussing how a DFS works. We are just going to use it. Okay, I'm expecting you to know what a DFS is. If you're not aware of what a DFS is, please go now and search in the Google. Okay, definitely will get some animations, and I remember in the Wikipedia also there is animation basically how a DFS works. Okay, so what we are doing here, if we are this, remember this is a recursive call. We are doing a recursive call. For example, all the left nodes first will be executed. That is, we'll visit all the left nodes first, and then we'll backtrack, and we'll go to one right node, and then so on. Okay, till all nodes are covered. So idea here is we are going depth wise first. Okay. For example, we'll go from 3 to 9, then we'll return back to 3, then we'll go till 15, return back to 20, and we'll go till 7. Okay. So only the depths are covered first. Okay. Not the breadth. So this is now local of answer. That is, answer is already defined here. That's what I'm trying to tell. If a node is none, return it. Okay. This is the condition to check leaf. Okay. This is the condition to check leaf node. If the left is also none and the right is also none, that is, as you can see here, the leaf nodes, as they have mentioned here, have no children. Okay. That's what I'm trying to check here. If the left node is also none and the right node is also none, okay, as you can see here, then it is definitely going to be leaf node, and its level, that is, how many nodes we have witnessed till now. Okay. That is a probable answer. That is one possible answer. So I am going to compare my answer with that. Okay, whichever is the minimum, the answer will be updated based on that. Okay, if it's not a leaf node, what I have to do, I can simply go and go down further. Okay, if it's not a leaf node, then that means it is a node in between. Okay, in between the root and leaf, so we can explore further. That's what we're doing here. We're expanding further. Okay, once this completes, what we are doing is, see, initially I've made my answer as this. Okay, so if the see here the constraints, the minimum see number of nodes in the tree can be zero also. That means no node is passed. Okay, if there is no node passed, answer will remain like this only. But definitely this is not the answer in that case, right? So we are checking if answer remains the same. That means the number of nodes in the tree is going to be zero. Okay, that's why we have written zero, because you see there is no depth in the tree because there is no tree at all, right? We have written zero in that case. In all other cases, we can return the answer. I can quickly run this and show you. As you can see, it's creating all the test cases. Okay. See, one thing I want to tell is that level I have used here. Level basically refers to the distance from the root normally, but in this case, I have used it as a depth. Okay, how many nodes we are witnessing in our path currently. Okay, so for the root, it will be one. Okay, that's what I'm trying to say. Please note these things. Normally, level refers to the distance from the root. Okay, as we go down, but in this case, I'm using it to store the number of nodes witnessed. Okay, both of them are almost similar, but see, when I talk of root, we are assigning the value one. That is the only difference. Normally, for root, the depth is zero, but in this case, I'm assigning the number one because that's what they want. Okay, they want the number of nodes witnessed in their path, so we have to count the root also. That's why it starts with one. Okay, here I'm not passing any value. If you want, you can pass also. You can pass one also. That's not an issue. But remember, you have to start with one. For rest all the cases, you will be explicitly passing the values. You will be always incrementing them by one. Okay. As we go down one depth, we have to increase these values by one because that's we are witnessing a new node, right? That's what it is. And if the node is not existing, that is, if suppose for example, uh, for for 15 there are no nodes, right? For example, suppose this 20 and 15, this whole subtree is not there. That means the right subtree of 3 is null. In that case, this code will be executed and it will be returning. Okay, that's what the idea is. So this question deals with all this particular answer deals with all possible cases, right? All possible cases. Like this is the condition for the leaf node, and for rest all the cases, even if there is one child or two child, whatever it is, this condition will execute it. In case of if there is one child for a parent, then this condition will help to return back. Okay, to backtrack. It's what it is. I hope this question you are getting clarity now. What is the minimum depth? Minimum depth basically refers to, you have to see, in all cases what will happen is that you are traversing from root to leaf. Okay, what is a leaf? Leaf is the endmost node. What is root? Is the starting node. Okay, so 3 to 9. Okay, in between how many paths you're witnessing, that you have to take account, and the minimum of such count will be the answer. As simple as that. I hope I have made the question very very clear to you. It's on the easier side. It should definitely be a strength for you. Okay, if you're able to solve this question easily, then definitely when it comes to tree, you will find it easier. Okay, if you're clear with what a DFS and what a VFS is. So yeah, friends, I hope you would have understood at least something new from this video. And if you have any doubts, please do comment below. If you like my explanation, please do subscribe. It really helps to give a boost to my motivation. And yeah, friends, we will see you tomorrow again. We'll meet tomorrow again. Thanks a lot.